What's up, everyone? This is LeetCode 198, House Robber. So, this is a DP problem, right? Just to preface that. So keep that in mind, right? So we're a professional robber. We're gonna rob houses along a street, and each house has a certain amount of money stashed. The only constraint is that you can't rob houses that are adjacent to each other because it'll trigger security systems and then automatically contact the police. If two houses adjacent are broken into, right? So we basically, this array basically represents a row of houses, and we just can't rob two houses next to each other. And we have to find basically what is the maximum amount of money we can steal from each house. And these numbers represent houses, or these values represent, each one represents a house, and the number, the actual value, is the amount of money in that house, right? So how much money can we steal, right, without taking from houses that are adjacent to each other, right? Basically, just find the maximum amount with that condition. Okay. Yeah, return the maximum amount of money you can rob tonight. I don't think the problem statement is that difficult to understand. The implementation is might be a little trickier. So we're gonna do that, okay? These are just example one, example two. Okay. So we're gonna need a DP array, right? We're gonna create that. It's gonna be empty, right? And the way we're gonna handle this is, so with DP problems, we generally are going to have to store some information and then reuse that later to cut down our calculations and just, kind of simplify the way we solve the problem. That's pretty normal, right? We've done that in in a few DP problems that we solve, right? You should be kind of familiar with that general idea of, let's store some information and then use that later to make our lives easier, right? Okay, so the way we're going to do this is, you'll notice in a lot of DP problems, you kind of need like a starting point, right? Because our DP array is initially empty. So we're going to start with the first house, which is a 1, right? And technically this, I pre-made these arrays, but they're actually too big. So 1, 2, 3, it's of size 4, right? So we're actually going to do, let's just like mark this off, okay? We don't need that. Okay. I made this before I put this in in this document. So we're gonna start with the first value, okay? Our DP array is initially empty. This is just the DP array, and this is the input array at the top, okay? So we're gonna start with 1, right? Well, the first house, right? We can, so far the maximum amount is just 1, because 1 is bigger than nothing, right? Why not rob the first house and make $1, okay, rather than 0? Okay, now when we get to the second house, that's kind of where we have to do a different thing, right? Because remember, we can take from houses, but not that are adjacent to each other. So how do we know whether we want to take the second house? Well, why don't we just compare the maximum amount before that to the current house, right? So the current house is 2. Is 2 bigger than the maximum we had before, which is 1? Yes, right? So we're gonna add that because that's bigger, right? If this house had a bigger number, we would just do that, right? Because we basically want to skip this house. Okay. Okay. Now here is kind of where, that's kind of like our setup, right? Those first two houses. And then beyond that, we're going to reuse these previous values now to kind of do our calculations, okay? Which is basically, we're going to do a comparison, okay? So when we're at dp of I, right? Which would be what, 0, 1 dp of 2, right? The way we're going to know what to populate this with is we're going to basically take, maybe I'll just spell it out so my handwriting's not that good. We're basically going to take dp of I minus 1, right? And we're going to compare that between nums of I plus dp of I minus 2. Okay, and I'll explain this really quick. So when we're here, right, we're going to basically compare what is bigger, right? Remember, we can't rob adjacent houses, right? So we're going to basically take this value and compare it to the maximum we had 2 houses back, right? And if that number is bigger than the house before, right, than here, then we know we want to keep robbing the current adjacent house path that we're on. What I mean by that is imagine we're going like this, right? And then like this. If that number is bigger than us just going like, okay, like, because basically what we're doing, I can't go back, there you go. Basically if we're hopping like this, boom, right? If these values when we add them together is smaller than this, well, we don't want to take those values, so we're just going to take this and put it right here, okay? That's basically what we're doing. We're basically comparing, do we want to rob the adjacent houses from, you know, from the jump of 1, 3, 5, or do we want to just take the skip that because that path is smaller than if we went 2, 4, right? You get my point? And so that's kind of the point of this. Okay, so we're going to do dp of I minus 1, right? So we're at 0, 1, 2. So 2 minus 1, dp of 1, right? Which should be here, obviously. Is this is 2, okay? And then we're going to take 3 plus, and then 2 spots back. So 3 plus 1, which would be 4, right? So which one's bigger, 4 or 2? Obviously 4, so we're going to put that there. Okay, we're going to keep doing that. Let me erase this, put this here, boom. Okay, then we're going to go to dp of 0, 1, 2, 3, right? 3 minus 1 is dp of 2, which would, obviously you're just comparing the previous dp value with the one two spots back plus the current I, right? So we're going to take 4, right? Compare that to 1 plus 2, which is 3, and guess what? The 4 is bigger, right? So that's what I mean where your path actually is going to diverge, right? If that makes sense, right? Because what I mean is, how do we know, again, we can't rob adjacent houses, right? How do we know if this path is best or this path is best, right? Well, why don't we, when we get to here, right, this is spot, we're just going to check this hop, right? But when we're here, we're going to check this hop against the maximum we've had up to this specific hop, right? And up to this specific hop, the max we had is 4, right? And that's bigger than this hop, which is 3, right? So we take our final solution for this problem, the actual output is going to be stored at the last dp index, right? So this 4 is actually the answer, right? I'm going to go here, right? Our 4 is the answer, right? Now we're going to do this one here, right? Remember, our first spot is just going to be populated by the first value. Our second spot is going to be the maximum, which is going to be 7, right? Okay. Remember what we're doing here, right? Let me copy this. I don't think I need to go this slow on this problem. It's not too complicated, but I will just to kind of make sure you understand conceptually what we're doing. Okay. So dp of I minus 1, which would basically, we're just comparing this value, right, which is 7, to 2 spots back, which is this 2 plus what we're on now, 9. Okay. Let me cross these out as we go, by the way. Right, so 9 plus 2 is 11. Is 11 bigger than 7? Of course, right? Okay, then we're going to go next. And again, this one is also, I pre-populated this array. We don't need this crap over here, right? So we're going to draw that away because our array is smaller than what I drew, okay? So where are we? We're at this 3, okay? So we're going to check 1 spot back, which is 11, right? And then we're going to do 3 plus 2 spots back, 8, 9, 10, right? Well, 11 is bigger, right? So we're going to keep that 11. Now we're going to go move to the next spot, which is this 1. We're going to check back, right? This 11, we're going to pass 11 with 1 plus 2 spots back. 11 is 13. And 13 is our final output, right? And whoops, I messed up my calculation somewhere. Let me see. 10, 11. Oh, sorry. I did 11 plus 2. It's 11 plus 1. Whoopsies. That's embarrassing. 11 plus 1 is 12. Right? And that makes sense, right? Because like our path could be like this, or which would be 10, 11, 12. Or if we had a different set of numbers, like for example, if this 7 was like a really big number, this path would actually be bigger, right? I'm trying to think. There can be weird cases. This algorithm will still work, but there can be weird cases like this where maybe we have a 10, like a 2, like a 6, and like a 20, right? Right, there can be cases like this where our best hop is actually not like this or not like this, but it's actually this, right? And so we're going to have a DP array, right, to show you how this is going to work. Okay. Remember, the first value is always going to be the first value in the DP array of the actual input array. The second value is going to be the max between the two, which would be 10, right? Now, when we go here and we're at the 6, right, we're going to go 2 spots back, which is going to be a 10, right? Which is bigger, the 10 or the, this, we're going to check 1 spot back, right? The DP of I minus 1. So we're going to check the 10 with the nums plus DP of I minus 2, which would also be 10, right? So 10 plus 6 is 16, right? Right? And we're going to go to this 20. Okay. So we're going to go 1 spot back, DP of I, right? What is the max between that and nums of I plus DP of I minus 2? Okay. So we're going to basically check 1 back, right? That's 16. And we have to compare that to what? To the nums of I plus DP of I minus 2. DP of I minus 2 is 10. So 10 plus 20 is 30. And that's actually our answer, right? Remember, the last index in the DP array will store the actual answer we need. So 30 is the correct answer, right? Just like 12 is the correct answer, and 4 is the correct answer for these respective problems. And that makes sense, right? Because if this is our input array and we need to rob houses, right? We don't want to jump like this because that gives us 16, and that's not the largest number. We don't want to jump like this because that's 22, and that's not our largest number. Our largest number is actually rob this house, skip this house, skip this house, rob this house, right? That's our biggest our maximum profit, right? And so you can have like weird thingies, like weird paths like this in terms of robbing houses. But our algorithm here, right, like doing these comparisons in our DP array, that will solve that will still account for these weird type of edge cases. But yeah, I just wanted to make you aware of that. Okay, and that's it. And now we're gonna go solve this problem in LeetCode. Okay, we're here back in C++. We can actually have an edge case where the length of nums can actually be 1, I believe, right? Yeah, the length of nums technically could be, I mean, we could be given an array of length 1 for whatever reason. So I guess we can just return 0 for that edge case. Always check your edge cases, right? Because it's kind of annoying, but they could give you random things like that. Actually, let me reset this. I think my I was gonna say my indexing is a little off. So we're gonna do length of nums. That's 1 for whatever reason. We're gonna just return the first value because there's only 1 value in the array. Okay, now here's basically where we do all our work. Let's just do our setup, which is just create the DP array, right? We're just gonna set it all equal to 0. You can set it equal to -1. It doesn't matter. These are just, I mean, these are just placeholders, basically. We're gonna have to populate this anyways. So we're gonna create our DP array. Okay. Remember, DP of 0, the first value is always just the first value of the input array. So we're gonna say nums of 0. And then remember, DP of 1 is going to basically be the maximum between the first and the second value in the input array, i.e. the 0th and the first index, right? So we're gonna say take the max between nums of index 0 and nums of index 1, okay? And now here is basically where we're going to iterate through the rest of the input array, okay? And this is kind of where like our quote-unquote formula is going to come in handy, okay? So we're going to say, what is DP of I going to be, right? What are we going to put in that? Well, we're just going to do a comparison, remember? We're going to take whatever the previous DP value is. Okay. And we're going to compare that to nums of I plus the spot two, the DP spot, two spots back. So we're going to say DP of I minus 2. Okay. I mean, I don't know if I should use spaces. I don't know what's cleaner. I'll just do it like that, whatever. And yeah, I mean, that's literally a problem. I mean, remember the answer is at the last index, so we just return DP of -1 to get the very last value in the DP array. And yeah, I mean, that should be it, unless I have some sort of weird syntax error. Doesn't look like it. Then we can submit that. We're all good, I believe. Boom, there you go. Anyways, I hope this helped. Yeah, it is a little tricky to come up with on your own, but I mean, conceptually it makes sense, right? Right? We're basically just looking at our paths, and we see if we see at any point that another path is more profitable, like if we see one of the paths in the past, quote unquote, meaning that's why we're storing our answers right as we go. If we see another path that is more profitable than the current one that we're on, why not switch to that path, right? And we do that by just basically checking this here, right? So anyways, I hope this helped, and I'll see you in the next one. Peace out.